Hello, this is the Promotory channel. Today I'm disassembling a Maschinenfabrik Augsburg Nuremberg D2876 F12 engine, which was taken out of this type of vehicle. And it has these technical specifications. So this is a 2008 model vehicle. The mileage is unknown. The current owner has driven it for about 100,000 kilometers. So what is the reason for removing it? Coolant is leaking outside between the cylinder heads, somewhere around the first, second or third cylinder. And I've already removed the heads, and I can see some not very good things with the block here. Most likely the block will have to be replaced. I'll also show you the heavy carbon buildup between the heads. This area is basically glassy now. Exhaust gases have passed through here for a long time, so everything is coked up and solid with burnt oil, carbon and dirt. So now I'll show and tell you what I've seen here and what not so good things are happening with the block. But first there will be some footage of how I disassembled the engine to this state. That is removing the transmission disassembly. sound. I disassembled the engine. And now, regarding the block, the first thing, as far as I can tell, I haven't taken any measurements yet. The sleeves appear lower than they should be. That's the first issue. And the second, right here we have corrosion. The block has been eaten away. Coolant is leaking from under the sleeve itself, and apparently it's been happening for a long time. We can see that the block has been eaten away here. But these are just preliminary thoughts for now. Of course, we'll take everything apart, remove the sleeves, clean everything there, and maybe take some measurements. For now, I think that most likely the block will have to be replaced. Here also on the second cylinder, there's a similar situation, but it's smaller here. It doesn't seem to be present on the others. By the way, let me answer this comment right away. There will definitely be people who ask why replace the block. You could try to patch something here, weld something on, or come up with some other fix. I agree, you can do something to get the engine working. Maybe it'll last for a couple dozen thousand, maybe 50,000 kilometers, maybe even, I don't know, close to 100,000 kilometers. I agree. You can come up with something here, machine the seat for the sleeve, put in an adjustment ring, raise the sleeve a bit higher, seal it with something here. But that won't have anything to do with a major overhaul anymore. Just like I recently had a rusty engine, a donor from England, and in this spot it was completely eaten away by several millimeters, and people wrote me so much about it. You can weld it, you can patch it, you can copper plate it, you can use cold welding. Well, anyway, I'll answer those kinds of comments. The customer comes to me for a major overhaul, so my job is to make the engine as good as possible so it will pass. I don't know, at least 500,000 kilometers, maybe 1 million or 1.5 million. And let's say spending 500,000 rubles, 600,000 or even 1 million rubles just for an experiment. Let's weld it here and see what happens. Spend 1 million rubles, and if it works, great. If not, you were just unlucky. That's why I try to do everything as high quality as possible, using only the best, most reliable parts, components, and so on. Of course, I can leave this block if the customer agrees. If the customer has no complaints in the future, if he understands all the risks, then by all means I can leave it, I can assemble it. But from my side, there definitely won't be any initiative to persuade the customer to keep such a block. That's 100% not going to happen. It's only if the customer insists on it. Consider those making these comments or giving advice. Try putting yourself in the customer's or my position and realize your car needs repairs. You're not earning money, but investing 1 million rubles and expecting it to operate and generate income after repairs. And you're being offered to do an experiment. Maybe it will work, maybe it won't. Would you agree to that? Those of you who write such comments. Personally, would you agree to that? I don't think so. Sitting on the couch drinking tea and watching a video is one thing. To write what seems like a so-called smart comment, give advice, and then go on with your life with a clear conscience, doing your own things, living your own life. And it's a completely different thing when it's your car or when you're doing this work. You have to spend a certain amount of money. You have to spend a certain amount of time. And I think that in the second case, the people who write those kinds of comments would have completely different thoughts, completely different demands, options, and so on. So now I'll also remove the fuel pump, take off the flywheel. Well, basically, I don't know. I'll take apart as much as possible, whatever else I can. I put the engine on the table, take off the oil pan, take out the pistons, the shafts, and so on. That's it. That's what we're doing. We keep working. So I've taken out the pistons, and what do we see? First, the bearings are repair size 0.25, and the repair was done in 2016. The bearings are from May 2016, and now it's the end of 2024. So this engine was repaired 8 years ago. If the crankshaft has lasted 8 years, we'll likely leave it as is. I'm generally not a fan of installing ground crankshafts, especially on an engine like the LF1276. It's longer, with an increased piston stroke and the connecting rod journal set further from the main journal, yet the bearings remain in satisfactory condition. Well, obviously we'll have new bearings. So as for the connecting rods, the rods will go for some side work. The first thing we'll need to do is check the seat for the connecting rod bearings for any elliptical deformation. If everything is fine here, then we'll replace the piston pin bushing, because there's this kind of play. If we have any issues here, like an ellipse, the connecting rods must be replaced. Well, since they're fractured, there's no way to restore them. You can't machine this surface to seat the cap lower and get the size we need again. So, fractured connecting rods can't be restored. Now, about the pistons. In general, the pistons are actually in excellent condition, judging by the skirt. I don't know, this carbon buildup here bothers me. There could be some serious scoring under this carbon. It happens, so I need to remove this carbon from one of the pistons and take a look. If everything is fine in this area and there are no scores, then maybe we'll keep the old pistons as well. I'm not sure about the liners. I need to remove and inspect them. The wear is minimal and some cross-hatch remains. Well, maybe the liner could have been damaged because of this, just like the block got corroded here. Maybe it's corroded under the liner too. I don't know. We need to take them out and check. Well, as an option, we could install new liners and new piston rings, keep these pistons and of course put in new bearings and so on. So we can also see that the main bearings are size 0.25, and on the main bearings we see the year 2012 marked, so it's unclear when exactly this engine was repaired. So now I'm removing all the main bearings, taking out the crankshaft and showing you. I just noticed something interesting with the connecting rod bearings, and honestly I don't even understand how that's possible. Also 0.25, but the bearing is from a different manufacturer, a different company. There's no year of production on it, so it looks like they assembled it from whatever was available. Oh! So this is the fifth main journal, the one I just unscrewed. The bearing also has a lot of wear. And you can see the shaft itself's got this kind of darkening, yeah, as if it was burned. We'll take more measurements and see. I'm filming the most interesting part on my phone to keep it focused, so first I'll show you what the main bearings look like. As you can see, there are some scratches and wear. And here are the three worst bearings. Well, actually two. This one is just a little worn. So, two of the worst bearings. These are the fifth and sixth main journals. And this one here is the fifth. And on the shaft, there's also overheating in this area. This is what the bearings installed in the block look like. These are the main bearings, and they all have a size of 0.25 ms, although they're from different manufacturers. As I mentioned, now the most interesting part is about the connecting rod bearings. This is the first cylinder, second, third, fourth, fifth and sixth. First, I'll show you the imprint. So let's say here's a bearing shell. We take the shell and look at it. Bearing size is 0.25. It'll be better this way. The bearing size is 0.25. 2016, just like I said, and the condition of the bearing is pretty good. So now let's look at the connecting rod where this bearing was installed. So we can see the imprint here. The bearing is 0.25 and 2016. This is our first connecting rod. We'll skip the second one for now. Let's move on. Third connecting rod, connecting rod, connecting rod. Spacer 0.25. It's clearly visible. The fourth connecting rod. The crankshaft is 0.25. The connecting rod is 0.25 at this spot. Here's the inscription sputer. Then the fifth connecting rod. Connecting rod. .25. Then the sixth connecting rod. .25 connecting rod. 0.2, 19. Year 19 standard once again. An imprint from the sputer inscription. An imprint ST02 25.00. We'll show the insert that was in that thing, the fruit one. It's still there. Sputer under. All our inserts are 0.25 except cylinder 6, which are standard inserts. So I took a micrometer. Here we have the sixth cylinder and I took measurements. First, let's measure the fourth connecting rod journal. So we can see the measurement. 89.75 piad millimeter. So that's exactly the size for 0.25 mm undersized bearings. The standard is 90 mm minus 0.25 mm. That totals 89.95. Fourth, next, fifth. We also see 89.70. Well, here it's almost 4. Yes, about halfway. Well, okay, 89.74. That's also about 0.25. Now, the sixth vertebra. So, as we remember, we have standard inserts here. If the inserts are standard, the journal size should be 90.00 or maybe 89.99, which is minus 1.02. We check the size of the sixth journal and see that its size is exactly the same as all the others.
89.7.
This is what I can't understand. The journal has been ground down to size 0.25, but standard bearings are installed. How did the engine run without the connecting rod knocking? I don't get it. And now here's the cherry on top. As we remember, we skipped the second connecting rod. Let's look at the imprint on the second connecting rod. Right here, 1.00. And now let's look at the bearing from this connecting rod. And what do we see? We see that it's true. The size of two bearings is 1, minus 1 millimeter. Now let's take measurements of the second connecting rod journal. We see the size is 80 8.99. So the standard size is 90 millimeters. 0.25 is 89.75. 0.5 is 89.5. 0.75 is 89.25. And one is 89.0. Well, here it's minus 100, so basically it's within the normal range. But the fact is that one journal is ground for the last repair to 1, while all the other journals are ground to a size of 0.25 millimeters. But for the 6 cylinders connecting rod, we have standard bearings, not 0.25. So, and also, if we look at the connecting rod, we see the first one and the second one. We can see right away that it's different. So at some point during repairs, this connecting rod was replaced. All the other 5 are the same. And the second connecting rod was replaced. Here we can even see the brand B. So what do we have here? At some point the bearings on this engine seized, the bearings on the second connecting rod seized, and one connecting rod was replaced. When the bearing seized, the crankshaft always bends, so our crankshaft was bent. That's why all the other journals were ground down to size 0.25, including the main journals. Because the crankshaft bend is usually about 0.15 or 0.2 millimeters. And to remove this bend, the crankshaft is ground down to the repair size. The first repair size is used, but if it doesn't fit, the second is tried. And they also ground the connecting rod journals because when the crankshaft is bent, the axis of the connecting rod journal still shifts a little. It's literally just a few hundredths there. And the second journal, where the bearing seized, was ground down to the last repair size. Well, apparently they were preparing the engine for sale. I haven't seen 2876 crankshafts run on the last repair size. Usually they break. They installed size 1 bearings and basically they sold the vehicle. And somehow the engine is still running. Somehow it still hasn't broken. The crankshaft, well, I don't know. Maybe the grinder was just really good and handled all the fillets, or maybe the crankshaft itself is just really well made. The engine has already run at least 100,000 kilometers after the repair, as I mentioned before. The customer bought it and has already driven 100,000 kilometers on it. Well, all right. I agree, that happens. I've seen that before. And we used to do the same thing at our company a long time ago, when there were big problems with spare parts, back when nobody was repairing these Mercedes engines yet. Maschinenfabrik Augsburg, Nuremberg engines, Mercedes engines. And at our company, we also did something similar and installed our domestic bearings, I think from EMZ. When the crank pin was already out of spec, they would machine it to a smaller diameter, big thicker bearings, bend them and make homemade locks. Alright, I agree that's possible. People do that for sale, there have been such cases. But for us to have a size 1 bearing installed instead of a 0.25 bearing, and for the car to still run after that, this is the first time I've seen this. I can't recall anything similar. It's very strange why this bearing didn't spin and why it didn't weld itself to the connecting rod journal. So we have an oil film clearance tolerance from 0.06 to 0.12 millimeters, which means this is 0.06. Well, roughly speaking, that's 1/10. Plus, if they took off 0.25 millimeters from the journal itself, that's 0.25, and plus another tenth. Each at about 3/10. We had a play of 3/10. We had a gap between the bearing shell and the crankshaft journal, and honestly, how the engine was working is a mystery to me. Well, one possibility is that the pump was so powerful that it created such pressure. And if we look at the imprint, we can see that these bearing shells are different. Here, the imprint from the connecting rod is a bit different. And on the 6th cylinder, we can see that it was being hit. There were impacts at. So, what we're going to do with the crankshaft, I don't know yet. We have two options: either buy a new crankshaft and install it so that all the journals and all the bearing shells are standard, or keep this crankshaft since it has already worked for some time. It has already run over 100,000 kilometers, so we can fit a size 1 bearing shell on this journal and all other shells at 0.25 millimeters. That would be riskier. As I mentioned, 2876. They generally don't last long after grinding. Well, I don't know what decision will be made yet. I'll take everything apart now, make a list, and get in touch with the customer. As I recall, we also have problems with the block. I think we'll need to replace the block. We'll take out the sleeves now and take a look. So it turns out that the main engine parts that need to be replaced are the block and the crankshaft. I don't know. As an option, maybe we'll get another engine and assemble that one instead. That's one possibility. My engine is disassembled. Let's sum it up. Well, I'll say right away, this is a unique case, an interesting case. So we have quite a combo here. First, the crankshaft is ground to various sizes with one journal at the final repair size. And second, in the 100 cylinder, instead of 0.25 millimeter bearings, we had standard bearings installed. I don't know how the engine was running. In my view, that's impossible. There's too much play, so you'd hear a lot of knocking, especially when running. I think the customer arrived for repairs just in time, a little more, and either the 5th or 6th bearing shells would have spun, or the connecting rod with the standard shells would have spun. We haven't decided what to do with this engine yet. I informed the customer about all these details and problems, that we need to replace the block, the situation with the crankshaft, and also what's going on with the camshaft. I don't remember if I showed it on camera. No, here the cam lobes seem to still be in good condition, but the bearing journals have these scratches, wear and scuffs. It turns out that the same journals where the bearings were are in bad shape. The 5th and 6th journals, metal shavings from them went through the channel to the camshaft bearing journal, and it also got scratched and worn out here as well. All main parts need replacement: block, crankshaft and camshaft. So it's easier to just buy another engine and repair that one, check its condition, and so on. Well, I don't know. We have two options here in my opinion. The first is to put everything back together as it is, meaning replace the liners, replace the piston rings, replace the bearings, the seals, the gaskets, and put it all back together. How long will it last? But again, that won't be a full overhaul. And the second option is to do everything properly. As I said, either look for another engine and rebuild it, or find a separate block, take it to the machine shop and do everything properly. Also get a new crankshaft, camshaft, pistons, etc. That would be a rebuild like the one I had with the engine from Moscow, but the repair cost over 1,000,000 rubles. Well, I don't know. Ultimately, all decisions depend on the customer. So, some time passed, about a week. So, the customer bought another engine, and it was purchased like this, without cylinder heads, without attachments, without the oil pan, as far as I know. The engine's original price was 750,000 rubles, but the customer negotiated a deal to buy it. Well, it's just a block, or the short block, so to speak, and in this condition. It seems like this engine cost him around 500,000 rubles. Basically, what we need from it is the block, the crankshaft, the camshaft, and possibly the connecting rods as well. So, that's it. Everything that was bought is here. Now we just need to figure out what condition it's all in. But according to the information we got at the scrapyard, this engine was repaired not too long ago. Of course, they didn't give us the exact details of when it was repaired, but they said it wasn't that long ago. Apparently, the customer even wanted to install it right away without taking it apart, just as it is, but then decided to inspect it and disassemble it after all. So now I'm taking it apart, removing the pulley, the front cover, the clutch, the basket, flywheel and disc are still in place. I'll take those off too, remove the housing, and then we'll take out the shafts and pistons to see what condition everything is in. So the engine is from 2008. I think it's exactly the same as the customer's. His car is also from 2008. We can see the condition of the bearings. This bearing is from the connecting rod of the fifth cylinder, the fifth rod. You can see there are these scratches. It feels like there was oil starvation, meaning the oil pump and the relief valve. In any case, we will be installing a new one. The condition of these bearings is even worse than the original bearings we had, which were 0.25 from this car. So the bearing is a standard one from the company Kess Kolbenschmidt. I don't see the manufacturing date, so it's unclear when the repair was done. Most likely these pistons will stay. As for the connecting rods, the bushings weren't replaced. You can see the play, it was clearly visible on camera. So in any case, the connecting rods will go to the machinist to check the seats for the rod bearings. If everything is fine with that, then the bushing for the piston pin itself, and its machining will be replaced. Well, as for the liners, I don't know. Maybe we'll even keep the same liners as an option, because they're also in good condition. They still have cross hatch with almost no wear. Well, first we'll take it apart and have a look. But as an option, maybe we'll just replace the seals under the liners, the piston rings, and of course the bearing. It's still unclear about the connecting rods. I removed the main caps and bearings, showed what condition they're in, and I'll show them in more detail later. They also have some scoring on them. And now, looking at the crankshaft, for example, this middle journal has noticeable wear. Well, it's probably about 700ths for sure. I don't even know what we're going to do. Anyway, that's about the crankshaft. I'll be upfront. There are concerns. We'll clean it, measure, and decide next steps. Let's go. The engine is disassembled. Let's summarize the results. As for the engine block, the block is basically in good condition in principle. We could assemble it with this one, but still, as I've said many times before, we're trying to do a complete overhaul. So we're doing everything as thoroughly as possible. Well, I'll also say that it all depends on the customer. So now I'll inform the customer about all this and we'll see what decision is made. My job is to make recommendations. It's the customer's choice to agree or not. But I will still strongly recommend running the unit at night and carrying out the full range of work with it. That means restoring the seats for the main bearings, beds, mating surfaces, cylinder head and liner seats. There are defects in all these areas. I can't show them on camera, but I'll display photos now. As shown in the photos, there's a defect on the partitions around the water channels. The block will undergo further machining on the liners. At first, I thought these liners would stay because it looked like the pistons were new and there didn't seem to be any scoring. But now when I took the liners out, I saw this situation. This is our fifth cylinder and you can see the scoring almost all over the liner and these scratches are present. It's due to the area between the first compression ring and the piston bottom. Carbon deposits accumulate there and that's how this carbon scratches and scores the liners. So this is our fifth cylinder, this is our third cylinder. Here we see just a small one and this is our first cylinder. The liners need to be replaced, but we'll keep these pistons. So we'll change the liners, the seals under the liners and install new piston rings. Regarding the push rods, as I said before, and for the bearing we can see their current condition. I don't know the year of manufacture or when the repair happened, but you can tell they're new. It's just hard to say when they were replaced. And also there's this kind of wear here, these scratches and so on. So the bearings definitely need to be replaced. Now about the camshaft. For now, at first glance, everything seems fine. The main bearings are in good condition. The cam lobes also look good visually. I'll take some measurements to the cam lobe height. But I think there won't be any issues with the camshaft. The camshaft will stay. Now about the crankshaft. As I showed, there's wear on both the main and rod bearings. Measurements show about 6 to 700ths of a millimeter of wear. I'm still unsure what we'll do about it. Also, for example, on the fifth main journal, there are these kinds of pits. It feels like it was sitting for a while and rust started to form here. As I've often said, I think it's better to leave the crankshaft with 4 to 600ths of a millimeter of wear than to grind it. The first repair size is 0.25. Well, I don't know. If someone asks me, will you guarantee that this crankshaft will work without any problems? Of course, I can't give a guarantee. How can I guarantee anything if there's already 0.07 millimeters of wear? It's tough to predict its behavior. But based on my many years of experience, 2 decades, my opinion is that it's better to leave the crankshaft as it is. Based on my experience, there haven't been any issues. The crankshaft keeps running normally. I already mentioned this when I disassembled the first engine about the turbine, electrical equipment, fuel system, etc. So all of that remains as is. So we have a different block, but we've had this one before. As for the machining work, everything is basically standard. The cylinder head mating surface, the seat for the liners, and the seat for the main bearings. So the engine was at the machine shop. The block was there for over a month. Well, we also had the New Year holidays and so on. So the machining work dragged on for almost a month. A couple of days ago the block arrived at my workshop, and now I'm starting the assembly so you can see what condition it's in. So some rust appeared here after washing. Mine wasn't this rusty, maybe it was stored somewhere. Plus it's winter, they loaded into the Gazelle into a cold cargo area, Duke. So in general we got this kind of rust, as you can see. Now I need to remove the caps. I've already unscrewed them here. They were tightened to working torque during the line boring. So I've unscrewed the caps and now I'm taking them off. I'm also removing all the plugs here in the oil channels. Well, basically everything is as usual. As always, I wash and blow out the channels, remove rust somewhere. In general, I'm preparing the block. I still need to clean some threads here, the seating surfaces for the gaskets where they sit, and so on. So I'm starting to prepare the block. But first, I'll show some footage of the work I've already done, the preparatory work. There was also an interesting moment with the cylinder head. It was a bit of my own mistake, or I don't even know how to put it. So next in the video, you'll see the footage that's already been shot about the preparatory work, and then we'll move on to preparing the block. So that's the scope of work we have. Let's go. Music. I'm checking the cylinder heads for leaks. This is the last one. I started with the 6th, 5th, 4th and 3rd are fine. But when I checked the second, I found a defect, and the first has the same issue. So in the hole where the cylinder head bolt goes, there's corrosion right inside the hole into the water jacket. We'll probably have to replace these two heads. Well, because it shouldn't be like that. As an option, of course, you could seal up the whole hole with sealant when installing the bolt, but that would be more of a patch job, not a proper overhaul. I don't like doing things that way. So, now I'm going to inform the customer that two cylinder heads need to be replaced, and we'll see what decision is made. Now I'll remove this bolt and put the cylinder head back on the boards again. Music. So I've assembled 4 cylinder heads and put them on the shelf for now. 2 of them, as I showed, have a defect. We have a leaky water jacket. So I called the customer and he said he would buy 2 cylinder heads from a salvage yard. Well, we have 2 engines here. Actually, one engine is from this car and the other engine the customer bought from a salvage yard. He'll get 2 cylinder heads and a set of bolts, but more work is needed on the heads. We'll need to take them to the surface grinder again. Then I'll have to lap the valves again, but this time I'll do the pressure test first and then lap the valves. Actually, the pressure test on these engines is basically just a formality. It occurs maybe once in 100 or 200 cylinder heads, and now we have 2 at the same time. I'm not sure. These cases keep happening more often. From now on, I'll do the pressure test first, then start repairing the cylinder heads. We're waiting on the heads for now. I still don't have the block yet either, but it should arrive from the machine shop in the next few days. They're working on the main bearing seats, the cylinder liner seats, and the cylinder head mating surface. So I don't have the block yet either. Basically all my prep work is already done. Almost everything has been sandblasted and cleaned. There's just a little bit left to finish up. So I'm still working on the preparations, and right now I'm going to work on the flywheel. So about the flywheel we're using is the one from the engine the car came with. Here's what I'm going to do with it. A new running ring for the oil seal will be installed. I removed the old one and it has some minor wear. Of course, I could have left it as is, but in my opinion, it's better to replace it while everything is disassembled. Next, we'll install the flywheel bearing. A wide one was installed here, but we have a narrow one with a spacer. I'm installing a wide one for its larger contact area, which seems more reliable to me. The ring gear will also be replaced. You can see the flywheel's ring gear in 3 spots here. Since we have a 6-cylinder engine, the crankshaft journals are positioned at 120 degrees. So the engine always stops in 3 positions. Accordingly, the starter also begins to work from these 3 positions. And you can see, like this, the teeth are almost half eaten away. I don't even remember if I've ever seen teeth this worn on a flywheel or its ring gear. So I removed the old ring gear from the engine that was bought at the scrapyard, took off the flywheel ring gear. The flywheel itself is in a bit worse condition, but the ring gear is good. We're taking the flywheel from one engine and the ring gear from another engine. Now what I need to do is heat up this race ring and install it hot under the oil seal. Then I heat up the ring gear and also install it hot. After that I install the bearing. Basically that's all for the flywheel. The work is done. Next I'll move on to working with the pistons. I still need to clean off some carbon buildup here, as you can see. Even though I soak them in special chemicals, there's still some carbon left. These deposits, which are right between the piston crown and the first compression ring, you can see that they haven't dissolved, so I need to remove them somehow now. EVA. And I also need to measure the height that was taken off the piston crown, which was done on purpose to get involved. On the cylinder head, it's about 3/10 of a millimeter, so I'll be removing about 3 to 4/10 within that range. Cylinder heads are ready, and I have the sandblasted manifolds here. We're just waiting for one more that the customer will buy. Here I have all the parts for the compressor. Basically I started assembling the compressor. There were probably some shots of it, and there will be more. The gear we have is the wrong diameter, so we returned it and ordered another. I'm waiting now. The compressor is almost ready. These 3 shelves on the rack are also from this engine. Here I have everything completely from the sandblaster. Every bolt, every tube, everything is washed, cleaned and blown out. So here you can just take anything and install it from this shelf. Basically I also have everything ready. I just need to clean this second part of the heads. The third rack is fixed and everything is ready, with bolts already prepared on the plate. We have places where the thread was stripped, so I already cut a new thread there. I also drilled this bracket, prepared the bolt, adjusted the length and so on. So I've already done a lot of work. I've been working on this engine for more than 2 weeks. Not much was recorded on camera, but almost all the preparatory work is already finished. That's it. So I'm working on the flywheel now, and then, as I said, we'll move on to the pistons. Let's go. Yesterday I spent the evening cleaning the block and now have some footage of it. So I removed all the plugs, blew everything out, washed it several times with this cleaner. It's a good thing, especially for cleaning oil channels. I blew everything out multiple times, wiped things down with rags here and there, and now I've already prepared the injectors, the plugs, some washers, and so on. Now I'm going to close all of this up. I started visually inspecting the channels, and in this channel, I don't know how to show it on camera. Basically, there's some kind of rubber sticking out there. I don't know if you can see it on camera, but I'll take it out now. It's not even rubber, it's some kind of plastic, like from a clamp. Or I can't figure out what it is. And how could it even end up in the oil channel? I mean, it got jammed in there like this. That's why you always need to inspect, even visually, if everything is blowing through. In any case, you need to inspect visually. I checked, and air passes through from all sides, all the inlets and outlets, everywhere the air goes through. But when I looked visually, I saw this thing. Well, of course, who knows what it could have done in there? It could have broken apart. It could have gotten carried somewhere, blocked some small channel, for example, on the connecting rod journal, and that's it. And our whole repair would have gone down the drain. Alright, now I'll carefully inspect all the channels visually one more time. Blow everything out again, then close up the plugs, the oil nozzles. And then I'll start installing the bushings, the camshafts, the camshafts. nutshell, I'll tell you what's going on here. I installed the crankshaft, tightened it, and showed how I tightened it. First we tightened to 330 Newton meters, then we mark across for a 90-degree turn, and then mark along the length. The crankshaft is fully tightened and still turns easily. I measured the axial play. The main journals show wear somewhere around -5, well, 5 to 6 in that range. So as I already said, in my opinion, it's better to leave the crankshaft with this kind of wear on standard bearings than to grind it down to the repair size that is for 0.25 bearings. Well, I don't know. That's just my opinion. Maybe someone thinks differently. Let me know in the comments. So, I still haven't installed one of the sleeves here. Yesterday when I was installing the sleeves, I was opening the boxes, and there, basically in one of the boxes, there were 3 upper rubber seals, or rather lower ones, the ones that go into the block. But the upper one was missing. They differ a bit in profile and most importantly in size. I wanted to find a rubber seal myself. Found one there, but then I thought, no, that's nonsense. It's too important a spot to put just any random seal there. So we ordered a new one today. And now I have a new upper seal, one Edling. Everything is as it should be. So now I'll install the sleeve. Then I'll install the pistons and connecting rods. I'll tell you about the pistons and rods now. The connecting rods were repaired. As usual, we checked the spot for the rod bearings and everything is fine here. And then the piston pin bushings were replaced. New bushings were machined. Basically, everything as usual. Everything standard. About the pistons remain old, meaning only the sleeves are being replaced. Sleeves, piston rings, and the seals under the sleeves. The pistons themselves stay old, but they're basically in good condition. The only thing is that there was carbon buildup in this area between the piston crown and the top compression ring. And when I was disassembling, I also told the customer that there would definitely be scoring under this carbon buildup. It's kind of a tradition. There are always some scratches. They're not that big, though I've seen worse before. So we're keeping the old pistons. So I clean off the carbon buildup with chemicals. I didn't put it in my washer because the solution I have now eats away at the anti-friction coating, and here it's in excellent condition, almost like new. So I didn't put it in the washer and cleaned it another way. On the piston crown in the combustion chamber, the carbon buildup appears to have come off, and this spot I showed you right here, so there was a thick layer, and this carbon buildup actually grows into the aluminum steel, so you have to scrape it off mechanically. It just won't come off otherwise. And after cleaning off this carbon, you can see the piston has these scratches and small pits further along. Well, almost all the pistons have these scratches. Some have more, some have less. I think these pistons will keep working without any problems. Based on my experience, I can say that I'm 99.5% sure there won't be any problems with these pistons. Here we have new main rings, 128, 4 plus 3 plus 4. Well, that's the height of the rings. They also come in different sizes. And here we have connecting rod bearings, new spotter connecting rod bearings, and they're tightened. With working force from the machinist, I unscrew the bolts, remove the caps, wipe and blow off something somewhere, install the pistons onto the connecting rods, install the piston rings, install the bearings. Oh, I also need to install the liner, and then I install the pistons into the block. I don't know, if everything goes well today, I need to close the front and rear covers. Everything is already ready for me. For example, the cover is prepared and everything is ready to close the oil pan as well. The cover is already washed, cleaned and degreased. A new oil seal is already installed here. Here are the studs. And good new nuts are also installed. Alright, less talk, more action. Let's go. So I installed the pistons. Already tightened the connecting rod bolts. We tightened them to 110 Newton meters, then turned them another 90 degrees across the marks, and the marks should be aligned lengthwise. So I've already checked that each cap and each connecting rod matches its numbered cap. I also checked that the main bearings are in order, and I made sure the oil nozzle fits into the recess on the piston. So everything is as usual. Everything is standard. I've installed the front cover and wiped everything down. I used sealant and all surfaces were washed, cleaned and degreased. The new oil seal was already installed. I tightened the gasket with sealant so the front cover is in place. Next I'm installing the rear cover. I've also prepared the gasket, the oil seal is new. As I showed here, I prepared the bolts and I'm also applying a thin layer of sealant on both sides of the gasket. Now I'm installing the housing. Well, I don't know, I'll probably install the flywheel right away before closing everything up here one more time. Check the timing marks to make sure they're aligned. Check the threads there and also made sure that all these oil plugs are tightened. Well, in general I double checked everything again, just like always. So I set the engine to its working position and I'm going to install the cylinder heads. I've already installed the homemade guides here. I took some out from there. Some I had to drill out. But in general, I've installed the homemade guides and my cylinder heads are ready. I showed what to do with the cylinder heads. So the first and second have been replaced. I showed that we had problems with two of the heads. There was leakage from these holes. There were pits into the water jacket. So all the heads are prepared. I prepared the bolts, sandblasted them, tried them on. So here I have 4 more original sets, genuine Maschinenfabrik Augsburg Nuremberg heads. And here are 2 more sets. These were also purchased together with these heads, 2 sets of bolts, because the bolts that were in these holes were also corroded. So I won't mix them up, meaning these sets are kept separately and these 2 sets are kept separately. Basically, of course, it's not that scary or important. Still, I think that 1 set of bolts should be used on one head the same way. So here I have the second part of the head with the rocker arm as well. I've washed everything here, cleaned it, degreased it, prepared the gaskets, prepared the sealant. This part with the head will be installed, set onto this sealant. I've also prepared the push rods, bridges and injectors. The injectors were serviced. We replaced 2 nozzles and kept foiled ones. So my task right now is to install the injectors into the head, but to check the protrusion of the nozzle from the head, it should be 2.5 millimeters. Here I have washers of different sizes. Now I'll tighten the injector so the washer gets compressed, and then I'll measure the protrusion. When installing fuel lines, I loosen the injector slightly for movement, install the line, and tighten it evenly on both sides. We also have rubber seals for the injectors. Two heads and 1.5 mm washers aren't enough, so I'll stack 1.5 mm washers. I'll also remember the remaining one is 1 mm, because the injector sticks out by 3.5 millimeters. At least on cylinder 12, my injector is set with 2 steps, but now I'm checking the other 4. I've adjusted the valves. Now I'll be closing the valve covers. Here on this side, I've already worked without the camera, installed the pipes, the diesel line, the return line, the main pipe, installed the fuel rail, the high pressure pipes. Here's the NASA point outlet, the main outlet. In general, I've already installed something here, tightened everything. So now I'll close the valve covers, close the air manifold, and here, I don't know. Maybe I'll immediately install the filter with maybe all the hoses now. So I'll keep working here further. My compressor isn't ready yet, only tomorrow or whenever I get the gear. So I still need to finish the compressor, and I also need to assemble the heat exchanger. So I installed the air manifold. Here are the fuel lines, the fuel filter. Basically, I was working here without the camera. This side is almost assembled already. Like I said, I still don't have the compressor. I don't have the gear. And basically that's it for this side. Here I laid out all the fuel lines. And as for the breather, I installed a new one. All I have left to do here is install the tie clamps, mounting clamps, and secure the wires with clamps. But I'll take care of that after all the wiring is fully installed, but that's not going to happen anytime soon. It won't be right now. Now I'm going to start assembling from this side. I'll start with the heat exchanger. I need to install the radiator there. As heat exchanger was welded on site, there was one defect. So I'll install the radiator, assemble the heat exchanger and install it. The heat exchanger is here. I'll install the starter a lot on this side here. Maybe I'll assemble it now. I also need to install the thermostats here. I'm putting everything together first. Then I'll get ready. The engine, painting and manifolds are painted separately. Once everything is painted, I'll install the manifolds. I'll still need to assemble some tubes, air, ducts and more. So the engine is ready. I've already assembled it here. And there's no compressor on the engine. So I just covered it with tape and left it like that for now. There's no gear yet, but we won't have any issues with it there. I want to install the gearbox so that it's already in place and then lay out this bundle of wires here. Now, about the sensors on the gearbox, so that the engine is ready for installation, it's just about the compressor, quickly assembling it. The repair of this engine costs this much. This is for all the work, all the parts included, but also, as we remember, the customer bought a second short block engine that is without cylinder heads and without attachments. So it turns out that the engine the customer bought is the one we assembled. We took the block from there, we took the crankshaft from there, we took the camshaft from there, we took the oil pan here and so on. I'm going to wrap up the video. Maybe next there will be some footage of installing the transmission, maybe installing the engine. I'll also try to film the first start. Basically, everything as usual, but that's it for this video. Thank you all for watching. Good luck to everyone. The engine is already assembled, already installed in the car, already disassembled, and I have the next engine ready. I've even done some work on this next engine already. I prepared the casing, overhauled the compressor, and so on. So what was the problem with this compressor? Here is the compressor drive gear. It has a small pit on one of the teeth. I'm not sure if I can find it right now. One tooth here has a pit indicating it's chipped. So, as I already mentioned, the compressor is a very important part of this engine, because if, for example, the bearing seize up or something goes wrong, if the crankshaft seizes, then the camshaft in the engine will also seize. And to replace the camshaft, you have to remove the engine again. Overall, it's a lot of work. It bends push rods, breaks rocker arms, can bend valves, and causes many other problems. I informed the customer about this, and the customer said, of course, let's replace the gear and install a new one. So we ordered the gear according to the part number, but the gear that arrived was 1.5 millimeters smaller in diameter. So it was supposed to be 75.5, but the one that arrived was, I think, 74. So basically, we returned the gear, ordered the next one from another manufacturer, and ended up trying all the manufacturers we possibly could. There were 6 or 7 gear options. Both we and the client searched, but all the gears we found were smaller in diameter. Well, I don't know. I haven't come across this before. If anyone has experience, write in the comments, can you use a gear of a smaller diameter? But what confused me is that the difference is not only in the outer diameter, but also in the inner one. The inner size of the teeth is also smaller by 1.5 millimeters. As an option, I think maybe the teeth there are a bit thicker, their profile is different, and the engagement works differently. Well, in any case, I told the client that I don't have experience with this issue. I've never installed pinions of a smaller diameter, so that's why it'll be an experiment if we end up installing a smaller diameter pinion. So, in the end, we searched and searched and finally found an original Machine and Fabric Augsburg Nürnberg pinion, and it's exactly the one we needed. So even if we look at the pinion itself, you can see here 0123. Also on this pinion 0123, well, that's the pinion number on the compressor drive compressors and on the mating pinion. And on this one, there are often these numbers. So we can see that we have exactly the same pinion as before. So it was decided to install the engine there. Obviously, there's a lot of work to connect everything, fill it up and so on, but we waited for the pinion. Now, my task is to assemble the compressor, paint it separately without the engine, and then install it on site. So, my task right now is to assemble the compressor. Everything should already be prepared and assembled, but I'm not sure. A couple of weeks ago, I replaced that rear bushing. The bearing is also ready and the heads are completely prepared. Here all the valves are new gaskets and so on.